If it's okay with you, I'm going to go ahead and make this drawing before we go on to the next slide. If we were taking this in a face-to-face setting, I would draw this on the whiteboard for students. So you recognize that according to Bohr and then Schrodinger, electrons actually are at different energy levels or potentially different energy levels. And the n is equal to 1, 2, 3, 4. Those are increasing energies. And we're going to use arrows to represent electrons. And boxes are actually going to represent those orbitals. We talked about where electrons are. Keep in mind that orbitals are kind of a location thing around the nucleus, and orbitals are also associated with a specific energy. So one of the things we'll be talking about, and it's the real deal, it's the way things really work, is if you could, first off, you see that box down there, that's an orbital. How many electrons are in that box? If electrons are represented by arrows. There are 2 electrons, and actually that's one of the rules. Now you notice that I have one pointed up and one pointed down. That's actually to show one of the phenomenon that happens with electrons that are sharing an orbital. You can only put 2 in there, you max out at 2, and if you have 2, they need to have what we call opposite spins, and that's how that's indicated by an arrow up or an arrow down. All right, so let's keep adding to that. So at the second energy level, n is equal to 2, actually there are what we say 2 subshells. And we'll be talking more about these different types of subshells, but there's an S-type subshell and a P-type subshell. So we call that 2S and 2P at the n is equal to 2 principal energy level. I hope that works for you. We're going to go up to n is equal to 3, and guess what? Dun, 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 it gets 3 subshells. Okay, so we're going to call that, what, 3S, 3P, and the last one is a D-type subshell. Now notice for the S, P, and D that has a different number of boxes. Boxes are your orbitals, and S's only have one box, one orbital. P's, regardless of what principal energy level they're at, will have 3 orbitals. And D's will have, we have kind of the oddsy thing going, 1, 3, 5. One last thing, and actually I'm going to have to kind of undo this as I've shown them increasing energy level. This isn't, I'm kind of lying here, but I'm lying on to try to make a point. Okay, principal energy n level, n is equal to 4. Guess what? You pick up the 4th and actually final subshell type that we need to worry about. So you might recognize 4S, 4P, 4D, and 4F. So the F-type subshells are going to have what? 7 boxes. So you have 1, 3, 5, and 7 for S, P, D, and F. And notice that it's not until n is equal to 4 that you pick up an F-type subshell. I hope that works for you. Okay, let's see what else we got. Okay, orbitals can hold 2 electrons each. That's it. Oh, I guess I went ahead and populated this. See how I'm adding electrons here? Ooh, I'm like a mad person. Yay, that's a lot of electrons. Okay, so I hope that helped. And again, I'm going to have to kind of come back and revisit this, and I'll tell you later how I lied on this slide. But that's kind of the general idea of how it works. So then on to a slide in your notes, and it looks like this. See, there it goes. Okay, so electrons are located within orbitals. Remember, I'm going to use boxes for the orbitals. A maximum of 2 electrons can fit in one box or one orbital. And if you have 2, then they have to have opposite spins, and we show that by one pointing up and one pointing down. Right. Orbitals then are going to be organized into subshells. We talked about subshell types on the previous drawing I made for you. We have the S subshell type, the P subshell type, the D subshell type, and the F subshell type. Okay, so there's that. And last but not least is that the subshells themselves then are organized in those principal energy levels, those n values that we looked at earlier. N is equal to 1, N is equal to 2, N is equal to 3, N is equal to 4, as far as I went on the previous little drawing I did. So notice when n is equal to 1, there's only one subshell type. When n is equal to 2, that's when you got your 2s and your 2p. N is equal to 3, 3s, 3p, 3d, etc. So I hope that helped.